In this video, we are going to review the process for using your graphing calculator to help you graph compound inequalities. Much of the graphing work that we are going to do throughout this year is going to happen in the same place in the graphing calculator, and it's not a bad idea to start practicing with a one variable inequality or compound inequality and graphing those solutions. That work that we're going to do is going to take place using the y equals button. Once we press the y equals button, we have locations where we can actually type in the names of the inequalities that we would like to graph together. So let's say in a hypothetical example, we're interested in graphing an and compound inequality. We're going to be looking at the space that's in between two numbers. In this case, a lot of our work is going to happen using the second test option. That's where the calculator holds a lot of its inequality and compound inequality features. So for our first example, we're going to say x is less than. Now, in order to type the less than, we're going to go second and into the test menu. And inside of this test menu, we see all of the different inequality symbols we might want to use. We're going to choose option number 5, the less than symbol. And we're going to say x is less than 8. Now we want to join that together with another inequality to form the entirety of the compound inequality. All of that typing is going to happen on this line. If we go back into this test menu, so we press second and test, or the math key, we now want to arrow over to logic, and there's our friends and and or. Because we're going to be looking at an and compound inequality to start, we're going to choose option number 1, and. And let's pair that together with another inequality that will be greater than. So let's say x is greater than, so option number 3, 5. So we have x is less than 8 and x is greater than 5. When we graph this, we should expect to see the solution space between the 5 and the 8. So when we press graph, we get a line segment that goes from x is equal to 5 to x is equal to 8. Now we're a little unnerved by the fact that this is all happening on the 2-coordinate system. That's not typically where we do the graphing for this. Obviously, we just normally do this on a number line. The calculator wants to graph everything in a 2-variable system, and that's the technique that it uses. Similarly to how we graphed an and compound inequality, we have the option to graph an or compound inequality. So we're going to go back into the y equals. Let's clear this one out to limit any potential confusion. And this time we'll do the exact same thing, but this time we're going to expect it to be graphing outwards. So we'll say x. Let's go back into the test menu, so second, math. We'll say 3 for greater than, and we'll say greater than 6. Back into the logic menu, which you get to by the same avenue that you took to get to the test menu. So into the test menu, arrow once over to logic. This time we're going to choose number 2, the or. And because I want to point the opposite direction, I want to say that I'm less than a number that's less than 6. So we're going to say x, back into the test menu, is less than, we'll say 2. So ideally, when I press this graph button, I'm going to anticipate that I'm going to have 2 arrows pointing in opposite directions. And that's what I have. Now, some might look at this and say, well, what I really have is just this absence between 2 and 6. Well, sure you do. The expectation was that you could be anything larger than 6 or less than 2. You can't be 3, 4, 5, 5.5, 4.2, any of those numbers that would fit in between. But you can certainly be in those numbers that are outside of 2 and 6. One potential downfall to using this, however, is that the calculator does not show you in a very precise way whether or not the 2 or the 6 are actually part of the solution. It simply gives you the range of solutions, and then you have, as the user, have to be well versed in this enough to know whether or not the 6 and the 2 are included. In this case, neither the 6 nor the 2 are included. There are no equal to's on either one of them, just as there wasn't any in the last example. So you need to be conscientious of that when it comes to making your decisions about what these graphs should actually look like, or should they include the open circle or closed circle that we've talked so much about.